Welcome to IOQM 2021 paper. This is the last part of the paper. So we'll cover 27 to 34 questions in this. These are all 5 marks questions. First, a bug travels in a coordinate plane moving only along the lines that are parallel to x-axis and y-axis. Okay. Uh, Let A is minus 3 comma 2 and B is 3 comma minus 2. Consider all possible paths that the bug from A to B of length at most 14. How many points with integer coordinates lie in the on the least one of these paths? Okay, how many points? So let me just show you. So this is uh, a graph basically. A is at minus 3 comma 2. Okay, this is x-axis, this is y-axis, this is 0 comma 0. Okay, this is 0 comma 0. So this is minus 3 comma 2 and this is 3 comma minus 2. Okay, bug has to travel from here to here. So if you see, there are 10 ways it can only travel x-axis and y-axis. It cannot go cross. Okay, so if you count it, maximum it can take is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. Okay, in 10 steps it can go from A to B. But he is given as an option that it can take at most 14. So it can go like a few steps here, 2 steps here, extra steps here, and take 2 extra steps here and get in basically. Okay. So how many such points are possible? That's the question. How many paths it can take? Okay. So A is at minus 3 comma, A is minus 3 comma 2, B is 3 comma minus 2. You take 10 steps from A to B, since we have maximum of 14 steps, we can add few more coordinates at each corner. Okay. How many we can add? Basically 2 steps each, because it will start from A, it go 2 steps back and come back 2 steps. So 4, right? So maximum we can add is 2 steps. How can we add 2 steps? 2 steps we can add like this. Okay. If these circled ones are not counted, basically. So if you take the circled one, how many steps it takes? 1, 2, 3 to come here, correct? Sorry, it starts from here. A is here, right? It starts from here. 1, 2, 3. It goes then 4, 5, 6. So it will become 6 plus 10, 16, which is not allowed, right? But let's say if you take this point, starts from here 1, 2, 3, 4, and then plus 10, 14. So that's allowed. So only these extra dots are basically at each corner are possible for this bug to travel. Okay. So now this is clear, right? This plane, coordinate plane. Okay. So the critical points are excluded. So circle points are excluded, because if bug goes to any of these points, then it will take more than uh, 14 lengths basically. Okay, the length of the path will be more than 14 units. Okay, so let's count now what is the coordinates. There are basically 11 uh, vertical lines. So minus 5 to 5, that is 5 plus 5, 10 plus 0, 11. 9 horizontal, 4 plus 4, 8 plus 0. Okay, so total paths are 11 into 9, that is 99 coordinates are there. Out of that, we should exclude only these circled ones, which are 12, right? So exclude these 12 corners, then you will get answer 99 minus 12, that is 87 is the answer. Okay. A problem, once you know the solution, looks very easy, but we need to get this idea of how to add these extra coordinates and how the bug travels, all this, right? So this is hard for a 10th class student, but I think by practice you will get it. Next, a natural number n is said to be good if n is sum of r consecutive positive integers for some r greater than or equal to 2. Find a number of good numbers in the set 1 to 100. So n should belong to 1 to 100. Okay. And any of the r integers you take, consecutive integers, so the sum should be belonging to this set. Okay. So let's see. From this set, we can count all the odd numbers. Why we can count all the odd numbers? Because each odd number, every odd number can be expressed as sum of two consecutive numbers. You take 5, 5 can be expressed as 2 plus 3. You take 13, it can be expressed as 6 plus 7. So every odd number can be expressed as two consecutive numbers, right? Integers. That means you have 49 odd numbers in this. So you take all the 49 out of, they're all part of the solution set. Okay, 49 now. Okay. Let k is the first integer and then r is consecutive integers. R consecutive integer sum is, if k is the first, then k plus 1, k plus 2 up to k plus r minus 1. This is equal to n. This is what we are trying to find. What is this k? What is the r? Okay. And this n should belong to this set basically. And now odd numbers we already calculated. So n is even. For even n, we will try. What is the, uh, uh, how many values we'll get? Okay. So this is a arithmetic progression. So sum is basically r by 2 because r terms are there, r by 2 into first term, that is k plus last term, k plus r minus 1. So you simplify, you get this one basically, kr plus r minus 1 into r by 2 equal to n. Take 2 other side, 2kr plus r into r minus 1 equal to 2n, right? Now 2n equal to, if I take r as common, 2k plus r minus 1. Okay. Now here 2n can be expressed as factor of two numbers. It's a even number, okay, and also it is factor of two numbers, obviously, right? Now here if you see r is, if r is even, this number will be odd. If r is even, 2k plus r minus 1 will be odd because 2k is even number, r minus 1 will be, if r is even, r minus 1 will be odd. Odd plus even is odd. Correct? If r is odd, r minus 1 is even. Even plus even is even. Correct? So these two have opposite parity. Okay? That means one should be even, other one should be odd. Okay? For 2n. Right? So this opposite parity is not possible among the set only for the 2 power x. Okay? Any number which is in the form of 2 power x, power of 2, you cannot express it with odd parity. Okay? So to satisfy the consecutive sum of consecutive integers, okay, is to be even, this we need to exclude because for power of 2 power x, we can never express that way. Okay. So example, if you take 4, 4 you cannot express as sum of consecutive numbers, right? You take 8, 8 you cannot express as consecutive integers, but you take 6, 6 is 1 plus 2 plus 3 you can express, correct? 10 you take 10, 1 plus 2 plus 3 plus 5 you can express. 12 you can express 1 plus 2 plus 3 plus 4 plus 5 plus 6, correct? So only thing not possible is, sorry, 12 can be expressed as, I mean, other sum, not 1 plus 1 to 6. Okay. So we should exclude 2 power x in this. Okay. So how many 2 power x are there? 1, 2, 3, 4, 5, 6. These 7 numbers basically up to 2 power 6. Okay. So if you remove these 6, these 7 numbers, then total will be 100 minus 7, that is 93. You will have solution. Okay. This requires some analysis of, again, you should be very good in number theory for such problems. Okay. And if you see most of the IOQM, I think maximum problems are from number theory and then geometry. Okay. So you should be very strong with these two concepts. Okay. With hard. Next. A positive integers a comma b comma c satisfy ab by a minus b equal to c. What is the largest possible value of a plus b plus c not exceeding 99? Okay. So this looks a little simple for me looking at the equation because it looks very odd, right? Observe that AB by A minus B equal to C, the minimum values, if you any this equation to be satisfied, let's take the minimum values. Okay. If all are one possible, no. If one both can be equal, no. A cannot be equal to B. So and since these are C is a positive integer, so A should be greater than B. Correct. So let's say a minus b equal to 1, that is 3 comma 2, then 3 into 2 is 6, c can be 6. Okay. So this is the minimum value you will get. If you take 2 comma 1, let's say 2 comma 1, then it is 1, then 2 into 1, 2, then c should be 2. Correct. So it can be 2 comma 1 comma 2. But in that case, there is a repetition. It cannot be a and c, right? A and c, this is equal to a then, right? AB by A minus B is equal to A then. These three are three distinct integers. So the minimum value you will get is 3 comma 2 comma 6 for ABC. A equal to 3, B equal to 2, C equal to 6. Now let us observe this equation holds good if A equal to KA means multiple of 3, B is same multiple of B, and C is multiple of C. Sorry, this is KC. Okay, you just substitute here k square ab by k into a minus b, so k square and k will get cancelled and k will remain here and c will become kc. Correct. So this equation holds good if abc are uh, multiples of same constant. Correct. So which means the equation we are looking basically is k times a plus b plus c should be less than or equal to 99. Now you define k with this. Okay. Minimum values of ABC are 3 plus 2 plus 6. Correct. So k into 3 plus 2 plus 6 is less than or equal to 99. So that is 11. Right. So k should be less than or equal to 9. Okay. So maximum value of largest possible value we are trying to look, right? Trying to find. That will come only if k equal to 9. That means a equal to 27, b is 18, c equal to 54. Okay. Now a plus b plus c equal to 99. This is the maximum value. Okay. This is easy, right? Next, find the number of pairs a comma b of natural numbers such that b is a three-digit number, b is a three-digit number, and a plus 1 divides b minus 1, and b divides a square plus a plus 2. Okay, so there are three hints given basically. B is a three-digit number, then a plus 1 divides b minus 1, and b divides a square plus a plus 2. Okay, that's it. So k into a plus 1 equal to b minus 1 because a plus 1 is dividing b minus 1. So k times a plus 1 is equal to b minus 1, which implies you solve for b, what you will get is ka plus k plus 1. Okay, note down this equation. This is very important for us. Okay, because when we get values, we'll substitute here and see basically validity of this. Okay, so ka plus k plus 1 divides. That's what is given, right? B divides this a square plus a plus 2. So b is nothing but ka plus k plus 1. So this divides a square plus a plus 1. That implies ka plus k plus 1 also divide k times this number minus a times this, because individually each one is divisible by this ka plus k plus 1. Correct? So combinedly also it will be divisible. Now, if you simplify this expression here, what you will get is 2k minus 1. Okay. So ka plus k plus 1 divides 2k minus 1. Okay. So if 2k minus, sorry, 2k minus a divides 2k minus a. If 2k minus a equal to 0, then ka plus k plus 1 can be any value. Correct. So let's see what is the possibility for that. A equal to 2k. If 2k minus A equal to 0, then A equal to 2k. Now let's substitute this A equal to 2k here. Then you get the B value, right? Okay. B equal to this value, which is equal to 2k square plus k plus 1. Okay. Now this is what B. B is this value. Now let us apply B is a 3-digit number, right? Given B is a 3-digit number. So it is between 100 and 999. This is B. Correct? Now you take this plus 1 out. So it will become 19. This 2 square plus k is between 99 and 998 inclusive. Now you divide it by 2. What you will get is 99 by 2. This expression is basically inclusive of 99 by 2 comma 499. That is 998 by 2. Right? Now I try to make this term as square so that it's easy to get a k value. Okay. Now I added 1 plus, 1 by 16 to all the terms. So it will become 99 by 2 plus 1 by 16. This is the expression, and then 499 plus 1 by 16. Now this middle expression will become k plus 1 by 4 whole square. Okay. And this remains same. Now from here, if I do a square root, apply square root on all, this is what it will become, right? K plus quarter is in between square root of 99 by 2 plus 1 by 16, okay, to the square root of 499 plus 1 by 16. So this close to 500, this close to 49, right? So K is between 7 to 22 inclusive, right? So K is the integer. So what are the values possible here? 16 values, 7 to 22, you have 16 values. So the answer is 7. Okay. So you will have number of pairs, A comma B pairs, basically 16. Okay. Hope you understand this. We are not trying to find what are the values. We are trying to find how many solutions are possible. Okay. This is also hard. You need some analysis here, right? Yeah. So that comes to end of 2024-21 IOQM paper. Now you can understand the SOF IMO and the real IMO. This is just a qualifier. Okay. So you know the complexity and you know the coverage of math. It really covers complete syllabus of math. Each question you need to apply multiple parts of the maths like algebra and geometry and number theory. I mean, you need to apply multiple things here, right? So that's the complexity. But everything is possible with a preparation. Once you start preparing, all these ideas, the tricks, whatever you see in these questions, you will remember. You will apply the same trick to elsewhere when you see a different question actually. These are all the math tricks you should learn for preparing for Maths Olympiad. Okay. Thank you. Hope I'll come up with more old papers because we can really cover good amount of syllabus with the old papers. Thank you.